Welcome to Listening to the Wind, IWSA's regular interview series. And I'm very pleased to say that I'm sitting here with Damon Roberts, DynaRig Authority at Southern Spas. Thank you, Damon, for joining us today.
Well, thank you, Gavin, for inviting me, and I'm particularly pleased having seen some of the other people you've had already a bit ahead of me.
Well, I'm sure you're going to really interest the audience. And before we launch into your presentation, which I know you have prepared, I'll just give a quick introduction. So Damon's a hands-on mechanical engineer. He's been responsible for design and build authority for many of the world's largest carbon-fired spa projects, including round-the-world race boats, super yachts, particularly freestanding rigs, including Aerorigs, Dynarigs on the Maltese Falcon, Black Pearl, and SYA rotating curved rigs. Along the way, he pioneered the development of optical fiber strain sensing, today used in wind energy, offshore vessels, including the super yacht rigs above, aerospace, oil and gas, and civil engineering, etc. He's also been responsible for the development of automated fiber placement techniques to enable the build of precision high loading CFRP pipes for the offshore ONG sector. With many such projects and prestigious awards behind him and his team, Damon is today the DynaRig Authority within Southern Spas, and together with many of the team responsible for the above projects, are currently working on a number of commercial vessel and private yacht designs for Dynarigs. So I think we are in very safe hands. I've got a feeling you might touch on Dynarigs today.
Absolutely right. I'm going to talk about the Dynarigs today and how we got to where we are effectively on the Dynarig. Oops, let me just go back to this. And
yep, fantastic. Coming through now.
Coming up slowly but surely. Yeah, I think we're online there. Just go back one. Yeah. So actually, I've entitled this little chat "The Evolution/Return of the Dynarig for Commercial Shipping," for very special reasons, which I'm going to come on to. So we're going to talk really a little bit about the Dynarig, what it is, and where it came from, and how it's manifested itself into the super yacht in recent times. A little bit about the track record of these vessels that are out there proving it. But then coming on to the main part, I'm going to talk about the commercial options, the commercial variants of the Dynarig for commercial shipping requirements, routes and costings, and basically it will be centered about how the Dynarig can enter into the commercial shipping world. So what is the Dynarig? Well, and where did it come from? In the 1970s, there was a fuel crisis. We're about to run out, and a German engineer by the name Wilhelm Prols developed what was called the Dynaschiff. That stage, you just see the nice picture on the left-hand side of the screen there of a multi-masted container ship or commercial vessel, which was used for wind tunnel testing at that time. A lot of research work went into that. Unfortunately, it never made it onto a full-size ship. The fuel crisis passed, and it gradually passed away. Roll on a few years, 2001, Tom Perkins, a very inventive, very wealthy American physicist, came to Perini Navy and asked for an innovative solution for an 88-meter private sailing yacht with the aim of being able to have a big yacht with lots of space with minimum crew, so that it wouldn't be surrounded by crew during the course of the whole thing. And Jerry Dykstra jumped on that, having previously read about the Dynarig and being a very innovative yacht designer who is more often associated with classic developments such as the rebuild of the J-class fleet and a few of the transatlantic schooners, but certainly someone who was very much up to speed, wanted to move forward. So he came up with a pretty interesting concept of the Dynarig. And They're funded by Tom Perkins on his yacht Maltese Falcon. We see this nice aerial shot of the Maltese Falcon, and you see the effect, 3 rigs effectively sitting on a nearly 90-meter yacht, 1,200 tons. And you can quite clearly see that the rigs are configured like an aircraft wing, i.e. they're curved. They in some ways they resemble old square riggers, but in some ways they don't. You know, the sails, when set, form a continuous shape, and you can see there are multiple sails set between the yards on each mast, 5 sails on each mast, and each sail is set independent of the others, so that when it does come out, it runs along tracks in the yards to create that continuous swing. And the beauty of it is that you divide all the sail power into 15 units, and you can increase or decrease those at will by yourself. So basically, simple sketch on the right shows the concept. Freestanding carbon fiber rig, no stays at all to the deck, with these permanently fixed yards set in front of the mast and attached to the mast by a fixed truss. The entire rig is rotating, controlled by a mechanism to drive it, which is embedded in the ship's hull. So there's no external lines at all. So what are the USPs? You know, clearly this really lends itself to is automated handling. And on these vessels, the big vessels we've done, left you see Black Pearl, all sail can be set by one person within 6 minutes. Just a touchscreen display, you set all the sails. You can recover the sails. You can actually sail on and off the mooring, or you can sail in and out of harbors. It is so easy. It is genuinely a one-person operation. And safety is another key aspect of this, partly because there are no highly loaded lines flogging sails to the deck. It means that in the case of a super yacht, crew and guests can move safely around, and there's no clutter to the deck plan. There's no interference or minimum interference. So you could have helicopter landing, etc., etc. But most importantly, a freestanding rig is kind of intrinsically safer and more reliable than the conventional rig, where failure through fatigue or overload of any single rigging element can lead to a mast failure. An example well shown in the aerospace world, where we've gone away from stayed wings to mono rigs. And the other key aspect of all of this, it is very green, and it's green because it's easy to use. You can set the sails at any point, and you can use them, so that the big boats that we have done with these sails use the sails far more than conventionally rigged boats, because it's so easy to do. So almost by the simplest possible way, they are saving fuel, i.e. they prefer to sail. It's easy to handle any point of sailing, and we can conserve fuel. The last boat we did, Black Pearl, also has energy regeneration capability, so she can genuinely cross oceans without using any fossil fuel whatsoever. One key aspect today that I like to emphasize is the DynaRig is a proven technology now. Through the development work we did for Maltese Falcon, which was very extensive, the vessels have got a combined over 20 years of seagoing experience already, cruised the world, 300,000 miles set. More importantly, something like 10,000 sail sets and recovery, exposed to hurricane type conditions on a number of occasions, 60 knots plus. And today, these vessels sail most of the time with their rigs, and don't use power at all. Also, an interesting point here, partly my background in fiber optics as well, is that these spars have an embedded optical fiber strain measurement, which allows us to monitor the loads at all times and to acquire complete load history of the spars, which can be useful for dealing with incidents, that if they ever happen, and we can look at exactly what has happened to the rig, what the crew did right, what the crew did wrong, what they could learn from it. Sails very cheap. And reliability and maintenance has been a key feature here. On none of our boats yet have these rigs been required to be removed. Most of the hardware is designed to be serviceable without removing the rigs. There's plenty of track history in the big boats, and there are many owners and designers out there that are particularly interested in pushing this for very large sailing super yachts. There's a selection of them there. But today, we're not here to talk about super yachts. We're talking about commercial rigs. And what is the difference for a commercial rig? And I've just outlined a few points here. Performance, reliability, operational experience. Those are aspects we can tick off completely. It's there, it's done, it's out there. Real-time route planning available is something that is increasingly better almost on a day-by-day basis, and is a significant way forward to commercializing wind-assisted shipping in all areas. I think most people recognize that. Maintenance costs are very low. But one of the issues is the initial capex outlay of a super yacht version makes it not viable for commercial applications today. However, that's the area that we focused on, and I won't go into too many details here, but you can clearly see that the complex fared-in interfaces that we've done on the super yachts, where smooth finish and beauty and aesthetics are also equally important and not needed. And we've come up with stronger, in many ways, reliable, simple, accessible solutions for this to enable us to build Dynarigs and their complex interactive parts at a fraction of the price that we can do it for a super yacht. And these are just some of the concepts that are coming through the next generation of commercial rigs. And some drawings here showing again how we can move into aluminium yards. For instance, again, at a fraction of the cost of the high-tech composite ones we've done on the super yachts. On a commercial vessel, weight isn't so important, and we can carry these weights aloft. Similarly, the mast spars can also be built in a much simpler way, and we do have one project today where we're looking at steel spars on that. The aim, of course, what's the aim? The aim is that these aren't vessels that are going to sail and only sail. I think whatever we do, there's going to be a hybrid form. They're going to use power as well. And there have been a number of studies done in a lot of detail in recent years over how this can be done. So here's a particular example of one vessel which has been studied in depth by the Dijkstra team and has published this data, and looking at a transatlantic route there, an out and back route following traditional routes to a certain extent, but using the benefit of all the wind data we have over the last 40 years or so. We've been able to plot the average times and durations of these voyages and work out the actual cost saving that could be done. Clearly, the cost saving comes in as a result of using the sails. And actually, if you want to keep a high speed all the time, you probably want to switch the engines on sometime. So actually, the control that is there to the owner is to decide what average speed he wants to achieve, and you can program it with today's weather routing techniques, and you will achieve that by a combination of sailing the right angles, sailing the right course, and motoring when appropriate. And by doing that, you save more money if you want to do go slower speeds, for instance. Here's a graph that shows that. So if you want to average 9 knots, then the running costs of the Ecoliner, in this case, substantially less than the classic equivalent motorized vessel. If you want to be averaging 13, 12 and a half knots, then actually the savings are not as good. And here in this particular work, reference has been made to required freight rates, and you can quite clearly see that in this case, at average transatlantic speeds of under 12 knots, the actual cost per freight ton per 1,000 miles is less on the ecoliner, taking into account capex and running costs than the equivalent vessel. So actually, by substantially cutting into the capex cost of the rigs, taking benefit of the improved weather routing conditions, and taking benefit of auxiliary power as well, you can clearly see today that it's an economical, actually economical game to be played here. It could actually, certainly break even and be even cheap, and in certain cases be cheaper. This is at today's rates, and obviously we don't know where we're going to go with fuel costs and penalties and taxes in the future. Hopefully they will also serve to enhance this calculation. So there are a number of commercial vessels out there at the moment. We're working very actively on two. Can't go into too much details because of the old NDAs, but you can see one of them here is a sea cleaner on the left for Ivan Boignon, who is building this vessel as a means to actually sweep the ocean of plastic as well, so achieving two things at once. And on the top right hand we have Daniel Doggett's three-masted actually a ship, cargo carrying ship, which can be containerized as well. So where are we? I think I'd just like to emphasize that DynaRig today is a proven, reliable and safe technology. What we're doing is commercializing it, and we're commercializing it by materials change, design simplifications, hardware development. It could be 100% sailing, but it's more likely to be motor assisted. So actually, that's basically a brief background to where we are on the DynaRig, and I think it could be. I just like a little quote here from. Just shift that over there. That's a Nobel Prize winner for literature. I'm sure all people of a certain generation will know who this is. The answer, my friend, is blowing in the wind. So Gavin, that's where I've got to on that, and I hope that's given a little bit of background to our approach to the DynaRig today, and how we've taken what was originally a vessel, a concept designed for the commercial world, which got hijacked into the super yacht world, developed into the super yacht world, and is now can be brought back into the commercial world. And it's a significant point, because through that mechanism, we've had the funding and the time to really hone the development of the system. And I mean that, we've spent a lot of time developing that sail handling technique that it can go in and out. We built a rig and put it on the ground, and we've ran it day and night through winter in Turkey, through winter and summer, through dust from the coal terminal next door and all these things. And we perfected all the intricacies, not just the hardware, but also the software, the control system, the control logic for the motors as well. And
yeah, absolutely.
That was a huge benefit. Not something that can be done lightly. That's not a few £100,000 worth. That's several £1 million worth of development and engineering knowledge that went together with a key team. So that sets the background now.
Indeed, and I think we're seeing this with as I've been working with IWSA, the trickle of expertise and knowledge coming back from the racing, the yacht fraternity, into the commercial shipping has been growing. It's not a trickle anymore. It's not quite a flood yet, but there's a lot of that expertise, and I think that expertise, that knowledge of how wind works over decades of testing, of real life experience, holds what the commercial shipping world thinks are new technologies, actually, as you say, are in a sense, reinvented or redesigned existing systems that have been so robustly tested in so many ways. So it bodes very well for the future.
Yeah, absolutely.
And
yeah.
I was just wondering, you touched on a number of issues. You were mentioning around the materials for the DynaRig sails. Has there been much development in that, or are you using fairly standard materials for the sailcloth?
We're using standard materials, and one of the beauties of the classic approach to dividing the sail area up into small components, and my sail making colleagues will probably shoot me for this, is that you break the load in the sail down into a much smaller amount. I mean, clearly 15 sails on a 3-master means that each sail is only seeing a 15th of the power that the vessel can generate, and because it's a square sail, that load is distributed along the length of its of the foot and the head, rather than 3 corner points which need massive loading. So the sail material can last a long time. It's not heavily worn. There's nothing for it to chafe on. There's no rigging, so that's helpful. But what's also equally important is that interface between the sail loads and the structure is really important to understand. And one of the reasons we are working with Southern Spars, with the North Technology Group as well, is to tie that knowledge together with the CFD and FVA programs, so that we can further hone the development of the structure, so that it marries to the sail, and the sail so that it marries to the structure. So that's certainly some work that's going on. And with that work, we are now able to effectively run a virtual wind tunnel type analysis. So we can also import into the models we have now the hull structure, the windage of the hull, the subsea element of the hull structure, the above the surface element, and we can analyze the vessel's performance on all angles of sailing like that, and produce effectively polar curves in all conditions, and marry that into the routing technology as well. So that's a massive,
so pretty much a digital twin, of your vessel.
Yeah, absolutely. Yeah.
No, that's, I mean, it's the advances there, that you're highlighting from what a lot. How can I say, the image or the perception of soft sail out there in the market is often probably the slowest one to actually develop and appreciate that it's commercialized. And I think the examples that you're giving there just show how much development there has been in this area. And the challenges around commercialization. You mentioned about for example, the fixtures or the materials that you're using on the spars. Those can be heavier. They can be how can I say, less pretty or less refined, more industrial. How has that process gone? I mean, was it very much a process of trial and error, or did you have a fairly good idea of where you wanted to take it?
Yeah, well, it's a good question there. I think, well, first of all, when you do the first one, it's always difficult. It's costly. If a lot of ships out there today, when you buy a lot of ships, you build them at a fraction of the price, and people can work that out at the price per ton. So I mean, when every ship is a custom designed unit and from scratch, that's expensive. The first thing is a route to volume is the key bit, but we have to get there, and it's like the crossing the chasm, and the early ones, we have to survive financially on those as well. So you're absolutely right. By now, with the benefit of the knowledge we have from the existing vessels, including the data, the load data we've got, and the performance of the hardware that we've designed, and everything's custom designed, every single fitting, we're now in a position that we can improve those in terms of how they're manufactured. Sometimes it's mass production, sometimes it's alternative ways of doing it, different materials. partly, aesthetics I mentioned earlier, and less demanding. I mean, we don't need a super yacht paint finish, for instance, which costs hundreds of pounds a square meter, things like that. But we're coming at it with the basis of we know what the loads are now, and we can design more appropriately for those loads and in the best materials. And I'm a mechanical engineer, and I've played around at designing and building things all my life, and I certainly fit into the category of choose the right material for the right job and the right price, and there is no such thing as one wonder material. You need to get the most appropriate one for the job in hand and do it. So material selection is really a key aspect to this. Also, we're designing to reduce the man hours going into the manufacture. So elements on the trusses, for instance, where there are multiple components for outhaul winches and manual drive unit and sensor technology, electric motors, we designing those into a chassis unit that can be disconnected from the rig with a couple of bolts. And when we build it, it is fitted out and tested on the ground and dropped into the rig. So we'll save a massive amount of hours into that sort of thing.
So kind of touching into that kind of modularization of the, standardization of the approaches.
Standardization, exactly like that. And so the prices will drop really significantly. We're already quoting, significantly lower prices for our commercial vessels, and I'm really confident that those will go down as volumes go up.
As orders go up, yeah, absolutely. And that's always the nice problem to have. Yeah, absolutely. So
getting there.
I've got one more question about your presentation, then we'll go on to some sort of wider questions about the industry. But obviously new build lends itself to substantial rigs. Is there any opportunity to retrofit Dynarig systems onto existing vessels?
Well, there's always a potential to retrofit. Is it likely to be economical? There was probably always the exception to the rule, but probably not. I mean, remember that a sailing vessel is working in two media, the air and underwater, and it needs the shape of the underwater shape as well in order to optimize its performance. So I think it's an area where there's some kind of misleading, or perhaps not 100% open discussions going on at the moment. That in order to really optimize performance of the vessel, it's important to look at the underwater aspects of it as well. And that could pretty well be applied to any of these concerns, you retrofit it, you may get some of the benefits, but you'll not get the whole benefit. And the cost of retrofitting is probably quite high in most cases. Someone will prove me wrong on that, because that's always the case. But we would say to people, go for a new build. I think it's cheaper.
Right. No, I mean that's a fair comment. And you mentioned, and coming on to sort of more of the, how can I say, the market or the business case out there. You mentioned, and nothing happens in isolation. You mentioned about the cost, the returns on investment, etc. And of course, we have both the regulatory driver and the price driver at the moment. With the regulatory driver, obviously, you've got EEXI coming through, the EDI, of course. CII is out there, which is going to be pressuring the operational side of things and efficiency gains to be made. But also we've got a carbon levies in discussion, the EU emissions trading scheme, potentially adding substantial costs to the use of fossil fuels. So what I want to ask you is, how do you see wind propulsion developing within that framework? And how much of a driver do you think those aspects will be?
Well, I was at COP26 recently, and I was really surprised and encouraged by how far advanced people's thoughts were around these areas, and there's no doubt that a combination of policies, penalties, and taxes and benefits will be really helpful moving forward. But equally, a general attitude from people as a whole is really important as well. I think if people really want to achieve it, they can do it. And so often we've got very, very, very close to the final point, and even though everything we put on the table showed that it was doable and could happen, it didn't happen. So there is a shift in the public opinion. It's not totally there, but there is a shift, and all of these things are going to help for sure. So I came away from COP26 actually surprised and very encouraged by what was going on in people who normally I'd be going and saying, well, why didn't you do this? Why you didn't do that? And they would say, we're gonna sort these things and help you guys get there. The humans also very inventive, of course. So it's when laws or penalties get imposed, if there's a financial way to optimize the existing solution in a better way, then I'm sure the people as a mass will do that as well. So it's not a foregone conclusion that
indeed
aims happen.
Yeah, no, indeed. I think you got that sort of carrot, you've got the stick there, but overriding that, is sometimes just a choice, or a passion or a vision that just says, you know what, okay, it makes economic sense. It may be difficult to do, but I'm going to go ahead and do this. I'm just going to push through and do this and innovate and deliver. So, and I think we're seeing those kind of companies and individuals stepping forward, which is always good to see.
And I think as well, as I highlighted early on, there's no single great material. There's no single great solution either. This is going to be a hybrid type of solutions running forward, and it will take time to work out the best combinations of motorized power, electric power, sail power, and as well. And I think that's a really sensible way forward as well.
And I think you guys have a fair bit of experience in that area. That with the onboard regeneration of energy as well to produce battery power or to produce an alternative fuel as well. And I'm sure there will be, and there already are, projects looking at that in the commercial sense. So some very interesting innovations. How do I put this politely? You're a well-experienced person in the maritime field. You've been around a few years, same as me, David. What changes have you seen? I mean, and let's narrow it down a little bit, because you've got a wide a wide portfolio of from the leisure and the yacht sector, but in the commercial sector, you were talking about the 1970s and Willem Prols and the designs around the Dynashift, but how have you seen the perception of wind changing? You touched on COP26 and a lot of people kind of looking at things differently, but specifically around wind propulsion, what has been the perception? Has there been a change in perception in your view?
I think there has been a change in perception, and it's an odd game. And I think one of the problems in our modern world is over control in many ways, and people in many ways have gone back to being more and more conservative in a lot of big engineering solutions. Certainly in the 70s, and there seemed to be much more appetite and enthusiasm to develop new things, and then we seem to get stuck into more and more controls and logistical requirements, and it's held us back a bit, I think. But I do see that is changing now, and it's and it's being reflected by increasing interest for sure from people who are in a position to do something about it. Yeah, and you do see that now for sure. And I think it's driven by mainly by the public interest. Politicians need to actually sustain public interest, so they kind of the tool that's driven by the public interest as well. And they, the idea of setting taxes and bringing extra money into this area seems pretty good. And so I think there is a lot more interest out there today. There's a lot more readiness to move into such solutions today than there were, say, 20 years ago. Perhaps less than there was 40 years ago, but
so we're getting back there.
We're getting back.
Yeah. Well, I guess in a sense, our job is to provide the toolbox for them to build the fleet that they want. So and there's only so much you can develop that. You could say this is credible, it's valuable, but at the end of the day, the ship owners, the cargo owners, and ultimately the consumers will ask for a fleet that delivers X, and hopefully that's a decarbonized fleet. And one of the quickest ways there is through wind propulsion. So just one last comment or bit of feedback from you. If you could select, the sort of the biggest barrier that's still around in your drive to bring your rigs into the commercial sphere, what would that barrier be, and how are you going to try and solve that?
That's an interesting question, because there are a number of barriers I think there. And I think one of the biggest barriers is possibly over expectation, particularly with large vessels. I mean, for a long time, we've known, obviously the weight of the vessel is going up as the cube of its length, effectively. The sail carrying capability can only go up as more or less as the square of its length. So and in sail driven power, it's horsepower per ton, the same way as it is in everything, really. And so you've either got to get more efficient rigs or more sail area, or both, and so and I've certainly seen some very large vessel proposals which don't seem likely to achieve very much, because they are so big. And maybe if you're only looking for very small percentage savings, that's fine. But if you're looking for significant savings, then I think we're going to be talking about smaller vessels. So I think there's an over expectation, and that's often driven within the industry as well. So I think that's a kind of a barrier there as well.
So some expectation management.
Yeah,
absolutely.
Yeah. And one aspect that I haven't really seen an issue, but you do see on the super yacht side, for instance, is again, crossing the chasm game of people who take up early technology, consider themselves as early innovators. They're a very special group of people, forward-thinking people, with a lot of drive and not afraid to take decisions, and they appreciate it. And often you haven't gone far enough with the technology development. So that's a little battle you have with those sort of clients who are actually the ones who are going to take it forward. So, well, hang on a second.
Can we do more?
Should we do more? Yeah, can we do more? And all the time, in our society, we have to survive financially. So we sometimes just have to be realistic on what you can achieve for the money. So it's going to be a step-by-step thing.
No, I think very much a learning feedback into the industry, and we're going to be going step by step forward. Yeah. So very quickly, I'm going to give you a couple of quick fire questions and answers. So this just a short phrase or a single sentence answer. Personally, how did you get into wind propulsion?
Well, I'm a hands-on engineer, as you introduced me. I love designing and building things and making them happen, and I got introduced to sailing early on. Well, actually, wasn't that early, about 12, 13, and on a lake, and I just loved it, and it gave me the opportunity to build boats and play around with them like that, and I did a sail training association trip on the Malcolm Miller, got me in a square rigger, and I ended up designing and building my own racing dinghies and boats, and we went into mast and just got bigger and bigger and bigger and bigger.
So living the dream.
Living the dream, yeah.
There we go. Excellent. And if you had somebody interested to go into design or naval architecture today, what or maybe you were speaking to your, I don't know, 18, 21-year-old self, what piece of advice would you give?
Well, I think with the development of new technology, there's one word, and I say test again. All the way through my career, I've just done that. I built things, and I've modeled, and I've tested it. I've worked out the mechanical properties, and we've broken it, and we've tested it, and we push it to the face so we understand it. So it's easy to come up with ideas, yeah. And a lot of people come to me with ideas, but you need to develop that, and you need to spend the hours and the time in developing it at a model scale, at a subcomponent scale, all these things. Test. That's what I would say.
I think that's excellent advice. Test to destruction.
Test to destruction. Test every component. Yeah. Push it hard.
Fantastic. And in your career, and obviously, if this could be from the commercial side, that's great. But from the yachting side, what's been the most difficult issue you've actually come across to solve?
I guess
that's a challenging one, isn't it? Yeah, maybe this question.
Yeah, it almost comes back to what I said earlier on. Sometimes over expectation. Yeah. That's kind of the challenging thing. I don't think you get anywhere by going at it, from the start small and go bigger and bigger and bigger and learn all the way along the line. That's my advice. There's always a series of tests and trials and things, but they're mainly kind of financial rather than technical, providing you follow that route that I've just mentioned, of thorough thought, think laterally, test, think laterally more and test.
Right. Okay, that's fine. The last question I'm going to, actually, I've got two questions for you. But these two I always ask my interviewees. So one is, and this is something that the commercial industry is increasingly asking all technology developers, is around the carbon footprint and the life cycle analysis of rigs, of equipment, etc. And I'm just wondering, is that something that you've worked on a lot, or is you're planning to be doing the footprint studies for your commercial rigs?
It's something we're planning on and we're working on, and we have done some probably fairly simplistic calculations of carbon footprints, and because there's it's not an easy calculation to really get right, and there's a lot of interpretations which some are less right than others, I would think. But I mean, for sure, a sailing vessel is making use of the wind, and but there are components there that require energy to produce them, as we know, and some of those components can be built by or produced by different techniques. So it's not an easy calculation. It does come back to where does the electricity come from? Again, is it a coal-fired station or is it a wind energy type thing? So but certainly Southern Spars have worked quite hard on that, and done some analysis on high strength composites, for instance, and the benefits analysis. And there's been quite a lot of work done in the aerospace industry as well, where obviously weight saving brings in itself massive energy saving as well. So they're complex calculation, but we are moving down that route as well.
Right. So it's in the folder. It's in the folder. Yeah, absolutely.
It's in the folder. Yeah.
along with everything else. Absolutely. Yeah. And the last one, you were talking about the fact that you've got quite a few projects coming through the company at the moment, and some really exciting commercial ones. And I know a lot of people out there are looking very interested at this sector now, because it is growing. Investment is coming in. It's early stages still, but it is coming in. So are you recruiting or building new teams to deliver this, or is it mainly being delivered by the team you have in place already?
No, we're recruiting. We're recruiting pretty hard, and I know exactly the sort of guys or girls we're looking for as well. So
so it's call me.
It's call me. Yeah. We like people that love working and love challenges and good attitude to it, and having fun, and making these things happen.
Well, it's a really exciting time to be coming into this sector, I think. Not quite the Wild West, but just space. I think space for engineers and designers to really, really put their minds to work and come up with solutions. So if I had my time again, maybe I'll be going down that route.
Yeah, I think it's really satisfying to get involved in projects like this, where you can see the issues from the beginning, and you can actually try and develop the solution to that, and we're going to build it, and then we're going to apply it, and we're going to see it through its life as well. So a key aspect to us, as I mentioned earlier, is the embedded optical fiber strain monitoring system. And also gaining all the other data that's coming in off the vessel, wind speeds, angles, the heel angles, all this stuff, and bringing all that together is really important. And being able to see these projects go through in a realistic timescale, it means 2 or 3 years. For a young designer or engineer, it's fantastic, because you start with nothing, and you go through the logic, and you get it, and it's out there, and suddenly, hang on, you're standing on that vessel, and you need to press a button, and the sails need to come in and out, or
fantastic. Yeah, no, absolutely, with the glass of champagne, of course.
Well, maybe a beer.
Well, Damon, I really appreciate you taking your time to be grilled by me, as it were.
Yeah.
But I'm going to give you just a minute now, if you'd like to give a sort of summary or a takeaway for the audience watching this. Please go ahead.
Yeah, well, thank you very much, Gavin. That's been really enjoyable, and I think you're absolutely right. We are entering into an era when sail-assisted vessels will be out there, and the DynaRig has had a huge amount of work put into it. It's out there, it's reliable, and it's working, and it's ready to get out there, along with quite a few other technologies as well. So let's go forward. Let's get these vessels out there and running on selected routes. And I think that's important. It's not a solution that's going to deal with everything, but it's going to be selected routes and selected services, selected types of vessels, and so on, and build on that.
Okay, you heard it here. You heard it here first. Thank you very much, Damon Roberts from Southern Spars. And I'm sure if anybody in the audience has questions for Damon, we'd be more than happy to answer those. And of course, on the wider wind propulsion sector and anything from any of the previous interviews, IWSA and myself, we're always happy to answer those questions too. So Damon, thank you very much for joining us, and we will come back for another Listening to the Wind interview in the coming weeks. Thank you very much.
Thank you, Gavin.